Welcome to the Teacher Tania channel. I am so excited you're here with us today. We are going to have a lot of fun because today we're looking at multiplication a little bit differently. I want you to imagine that numbers aren't just boring symbols on a page, but rather they're a group of friendly characters who love to hang out, swap places, and form little clubs. In this explainer, we're going to read through the ultimate math rulebook to learn the properties of multiplication, drawing on some really fantastic lessons and quizzes from IXL and Khan Academy.
Here's our game plan for this explainer. First, the rules of multiplication. Then, commutative, changing the order. Third, associative, grouping the factors. Fourth, identity and zero properties. And finally, number 5, the distributive property.
Section 1. The rules of multiplication. Building your math toolkit. Section 2. Commutative property. Changing the order.
You know, when you're in the 3rd grade, multiplication can kind of feel like a whole lot of memorization. But honestly, these rules show us that numbers actually behave in really predictable, super friendly ways. They love to help you find the right answer, and our very first rule is where they love to just move around and dance. The formal definition from Khan Academy says, changing the order of factors does not change the product. Now, a factor is really just a fancy math word for the numbers you're multiplying, and the product is your answer. So what does this mean in simple terms? Basically, our friendly numbers can completely swap places in line, and the end result is exactly the same. It's like looking at visual groupings, like bright red apples. If you have 4 rows of 3 apples or 3 rows of 4 apples, well, you still got the exact same amount of fruit to eat.
And this brilliantly illustrates the whole concept right here on the screen. On the left side, our friendly number 4 is standing first, holding hands with the 3. They multiply together to make 12. But over on the right side, the 3 decides to jump to the front of the line. Now it's 3 times 4. But look at the answer. The product is still 12. Just like those rows of apples we talked about, changing the order of the numbers absolutely does not change how many we have in total.
All right, let's pause for a quick second and make sure you've got this. We're going to test your knowledge with a real interactive question straight from the Khan Academy source material. Ready? Which of these is an example of the commutative property of multiplication? Okay, so we have 2 options here. Option A shows 2 times 6 equals 4 times 3. Now, sure, both of those equal 12, but are the friendly numbers just swapping places? No, they are totally different numbers. But take a look at option B. 3 times 5 equals 5 times 3. If you guessed option B, you are spot on. The factors 3 and 5 just neatly swapped places. That right there is the commutative property in action.
Section 3. Associative Property. Grouping the factors.
So, while the commutative property was all about swapping places, the associative property focuses on the power of parentheses and how our friendly numbers really like to form little clubs. Khan Academy defines the associative property by stating, changing the grouping of factors does not change the product. This basically tells us that no matter how we group the numbers together to multiply them first, the end result stays exactly the same. You can think of parentheses in math like big hugs. They tell you, hey, do the math inside here first. But with multiplication, it literally doesn't matter who hugs who first. Here we have 3 friendly numbers just hanging out, 2, 3, and 4. On the left side, the 2 and the 3 are in a parenthesis group together. It reads, parentheses, 2 times 3, parentheses, times 4. But on the right side, the grouping shifts. The 2 is left outside, and the 3 and 4 are grouped together. Notice how those parentheses shifted around to tell us which part of the equation to tackle first. But since they're all multiplying, will they get the same answer? Let's prove it by evaluating the left side step by step. Step 1, we look inside the parentheses and multiply the 2 and 3 first. That gives us 6. Step 2, we bring down the 4, so now we've got 6 times 4. And step 3, 6 times 4 gives us our final answer of 24. Now, if we did the right side, where the 3 and 4 were grouped together first, we do 3 times 4 to get 12. Then multiply that by the 2 waiting outside. And 2 times 12 is, yep, you guessed it, 24. The grouping didn't change the outcome at all.
Let's put this to the test with another quick multiple-choice question. Remember, we are looking for the numbers to stay in the exact same order, but their parentheses groups are shifting around.
The crucial point here is how the groupings shift. Let's look at option A. 3 times the group of 7 times 4 equals the group of 3 times 7 times 4. The numbers 3, 7, and 4 are in the exact same order on both sides, but the parentheses actually moved. Option B just repeats the exact same equation without any grouping changes whatsoever. So option A perfectly demonstrates the associative property.
Section 4. Identity and zero properties, the magic numbers.
Now what's really interesting here is how simple
and honestly how fun the rules become when we introduce our two magic numbers, 1 and 0. They each have a very special superpower. First up is the identity property. Khan Academy defines this as the product of 1 and any number is that number. Basically, whenever you multiply a friendly number by 1, it maintains its unique identity. I always like to think of the number 1 as a magical mirror. Any number that multiplies by 1 just looks into the mirror and sees itself right back.
Notice how 7 times 1 equals 7. The 7 looked in the mirror and stayed a 7. And thanks to the commutative property we learned earlier, we know that friendly numbers can swap places. So it doesn't matter if the 1 comes before or after the number, the result is exactly the same. 1 times 6 equals 6. The identity is perfectly preserved.
Moving on to the 0 property, which is actually my absolute favorite. IXL gives us this incredibly memorable and punchy key idea in their lesson. Multiplying by 0 always gives 0. So, if the number 1 was a magic mirror, the number 0 is a total magic vanishing trip. Take a look at this equation. 8 times 0 equals 0. The 8 completely vanished. 0 times absolutely any number in the universe, whether it's 8 or 100 or a million, will always result in a big 0. It's kind of like a tiny mathematical black hole. All right, let's pull up a quick, interactive quiz straight from the IXL learning platform to lock this concept in. We are looking for that magical vanishing trick in action. Which equation shows the 0 property of multiplication? We have 3 options here. Option A shows repeated addition, which, is how multiplication works, but there's no 0. Option C shows 4 equals 4 times 1. Wait, that's a number looking in a mirror. That's the identity property. But look at option B. 0 times 6 equals 0. The 6 vanished. If you spotted option B immediately, you have completely mastered the 0 property. Section 5. The distributive property, breaking it down.
Finally, let's look at our last rule for today. This is a topic that actually generated a lot of great questions in the Khan Academy comments section, mainly because it combines multiplication and addition. But don't worry, it's really just our friendly numbers deciding to go on a visiting spree. On the left side, we have the number 4 standing outside the parentheses, and inside we have 5 plus 8. Think of the 4 as a friendly neighbor who wants to visit everyone inside the house, the parentheses. As one very helpful user in the comments clarified, the distributive property tells us we can distribute the multiplication of 4 across both the 5 and the 8. So the 4 visits the 5 to make a group of 4 times 5. Then the 4 visits the 8 to make a group of 4 times 8. Add those two visits together, as shown on the right side of the screen, and you get the exact same answer as if you added the 5 and 8 first. It's an amazing trick to break down tough math problems into much smaller, easier pieces.
And why is this so important? Well, because as the IXL curriculum outlines, this property actually grows with you. Right now, you're using the distributive property with standard numbers, but as you get older and advance in math, you'll use it to solve puzzles with letters, called variables, and you'll even use it to build visual area models to calculate space. It is a really powerful tool that will stay in your toolkit for years to come. And just like that, we've reached the end of the rulebook. Armed with the commutative property to swap places, the associative property to form groups, the identity and 0 rules to do magic tricks, and the distributive rule to break things down, you have absolutely everything you need to master multiplication. So I want to leave you with a question. Which of these friendly multiplication properties is your favorite, and which one are you going to use to conquer your next math problem? I really want you to encourage your brain to keep thinking about this, so please leave a comment on this explainer explaining some of the properties in your own words, or just share your favorite analogy. Let's see who has the best explanation. Thanks so much for learning with me today on the Teacher Tania channel, and I will see you in the next explainer.